gear A is given an angular acceleration. So this gear A is having an angular acceleration 4 times t to the power 3, and t is in seconds. Alpha of gear A initial, sorry, not alpha, omega of gear A initial angular velocity of gear A is 20 radians per second. Find the angular velocity after 2 seconds. So you have to find out the angular velocity. That's easy. And angular displacement theta A after 2 seconds. So let's do this. It's not difficult. You know that alpha equals to time derivative of the angular velocity, and I'm given 4 times t cube as alpha, and I can just cross multiply this dt over here and do the integral. So this is the formula which you have to find out from 0 to a certain value. So omega minus omega 0, and from 0 to 2 seconds, 4 times t to the 4 over 4, and apply the limits of integration. So 4 is left as 2 to the power so what do you guys get? Omega naught is given, which is 20 plus 16 gives you 36 radians per second after time 2 seconds. This is the first answer. And the second answer, you have to find out the angular displacement, and we already know the formula for the omega equals to time derivative of the angular displacement. That means angular displacement can be found by the integral of the omega from certain value of, like, from 0 to theta, from 0 to times 2. What is omega? Omega we already calculated here. So let me write down the expression for omega. Omega expression is t to the 4 plus omega sub naught. So I can write down here, the left hand side is theta minus 0, the right hand side is omega naught plus t to the 4 whole integral omega naught t plus t to the 5 over 5, and plug in 2 0, and if you do the work here, omega naught is given, which is 20 times 2 to the 5 divided by 5. You should get 46.4. Let me double check this. 2 to the 5. 6.4 plus 40, this is 46.